Students, welcome to my YouTube channel. In this video lecture, I am going to solve the last set of questions, the last 10 questions remaining from Radar Theory chapter, Heath Williams Radio Lab. Previous video lectures I have solved the first 30 questions. I hope you have watched those lectures, solved the questions, and now you're comfortable answering them. So in this video lecture, let's do the next 10 questions. That is the last set of 10 questions. I also suggest that you do the questions from Oxford book. I have solved those questions also and uploaded to my YouTube channel. Question 31. Assuming sufficient transmission power, the maximum range of a ground radar with a pulse repetition rate of 450 pulses per second is so and so. What is the maximum range? What is the range? So PRF frequency is frequency is 450 pulses per second. Range is speed divided by 2 into frequency. So range will be 3 into 10 raised to 8 meter per second divided by 2 into 450. So 2 into 450 is 900. So 3 divided by 900 is 3.33. 3.33 into 10 raised to minus 3 into 10 raised to 8 meter. So range will be equal to 3.33 into 10 raised to 5 meter, that is equal to 333 kilometer. 333 divided by 1.85 is 180 nautical miles. 180 nautical miles. Okay. So option alpha, 333 kilometer or 180 nautical miles. Question 32. Again, range is given to us. We have to find out PRF, frequency. So range is equal to speed of light divided by 2 into frequency. So frequency will be speed of light divided by 2 into range. 3 into 10 raised to 8 meter per second divided by 2 into 50 kilometers multiplied by 10 raised to 3 meter. We want equal units, meter, meter, both in the numerator and denominator. So 3 into 10 raised to 4 by 2 into 5. So 3 into 10 raised to 3 meter, that is 3 kilometers, right? 3 kilometers. Or 3 divided by 1.85 is 1.6 nautical miles. So answer will be 3 kilometer or 1.6 nautical miles. Question 33. The maximum range obtainable from an ATC long range radar, area surveillance radar, is what? So as given in the textbook, it is 200 to 300 nautical miles. 200 to 300 nautical miles. Option Charlie. Remember this. Next. Question 34. Frequency is given to you. What is range? Range is equal to speed divided by 2 into frequency. So range will be speed of light 3 into 10 raised to 8 divided by 2 into 1200. So 3 divided by 24 into 10 raised to 6. 3 divided by 24 is 0.125 to 10 raised to 6 meter, या फिर 125 kilometer, also known as also 125 divided by 1.85, 66.5 nautical miles. 66.5 nautical miles. So option A is the correct option. Next, question 35. Considering a primary radar system, what kind of aerials are used? Directional antenna for transmitting, omnidirectional for reception, one directional antenna for transmitting, another directional antenna for receiving, one directional antenna for both transmitting and receiving an omnidirection. So correct option is option Bravo. Since primary radar operates on one specific frequency, it will transmit a radio wave on one frequency, it will receive that wave, that reflection of that wave from the target from at same frequency. That's why it is going to only use one particular aerial both for transmission and reception. That saves costs also, cost and weight of equipment. So one directional antenna for transmitting and receiving. Pairing a parabolic reflector with a flat plate antenna. Flat plate antenna is nothing but slotted array of the same size. What are the advantages? The parabolic reflector generates less side slopes than the flat plate antenna. The parabolic reflector has a considerably smaller beam. Flat plate antenna generates less side slopes than a parabolic reflector. Flat plate antenna has smaller beam width. So the correct option is option Charlie. The flat plate antenna generates less side slopes than the parabolic reflector. You can find this fact in the last paragraph, in the last page of Oxford Radio Nav, chapter number 11, Basic Radar Principles. Question 37. When an operator increases the range on a radar display, in general, okay, when operator increases the range, the PRF becomes higher and the pulse length smaller. The PRF becomes lower and the pulse length larger. Both PRF and pulse length decrease. Both PRF and the pulse length increase. Very important. The maximum range limited by pulse recurrence frequency. It is inversely proportional to pulse recurrence frequency. Minimum range is determined by pulse width. When the ATC radar controller increases the range on a radar display, that means he increases the range on his radar display. So this is the radar display of the ATC screen. There is a transmitter in the center and there are many circles representing different ranges: 10, 20, 30, 40, 50, so on and so forth. So when if you want to increase the range, that means you want more and more range on your radar display. So what will you do to your frequency? The frequency should decrease. So more range, less frequency, since it is inversely proportional, right? So option alpha wrong, delta wrong. So PRF becomes lower. What about pulse length? Pulse length larger, pulse length decrease. Okay, so Bravo is the correct option. Pulse repetition frequency becomes lower. Okay, you will send fewer and fewer pulses every second. Okay, and in turn pulse length will be larger because we know that frequency is inversely proportional to range. So if you are decreasing frequency, now there is some space for pulse length to become larger. So Bravo is the correct option. Pulse length larger. Echoes that do not change in distance from the antenna. Okay, that means fixed targets. Now echoes do not change in distance. Now let's say there is an aircraft. This aircraft will move in the atmosphere. So that means this aircraft uh, will move with respect to the transmitter. But fixed objects like mountains, buildings which are surrounding the transmitter, they won't move in space. That's why they are called. That's why the reflections coming from these fixed objects like mountains, buildings will remain the same. They won't change in distance, right? So echoes that do not change in distance from the antenna, okay, that means the relative speed is zero. They are fixed in space. With a moving target indicator are dangerous for the following reason. The moving target indicator eliminates such echoes. The radar is not able to display two echoes moving in the same direction. The MTI does not recognize this as a moving object due to blind speed. The frequency of the transmitted changes too much by Doppler effect. So correct option is option A. Now moving target indicator is a special radar display which will only represent or which will only display the signals generated or the radar blips generated from moving targets like aircraft, helicopters, anything. And it will eliminate echoes, reflections of radar beams from fixed targets like mountains, buildings, structures like that. Okay, so remember that. So if these echoes are eliminated, if the echoes from mountains or any fixed structures like buildings, antennae are eliminated, the radar controller will not have any idea of the existence of such mountains or any high-end structures. Okay, in the range of the radar. So if the ATC controller has no idea of that existence, it will by mistake, the ATC radar controller can by mistake navigate that aircraft or lead that aircraft into that mountain or somewhere near that mountainous structure or any other structure. So that becomes a danger. Okay. So remember that. 39. The maximum range for airborne weather radar is determined by what? Transmission power, size of the aerial, transmission frequency, pulse recurrence frequency. So maximum range is limited by pulse recurrence frequency. Minimum range is determined by pulse width. Okay. Last question. The advantage of the use of slotted antennae in modern radar is to what? Virtually eliminate lateral lobes, side lobes. As a consequence, concentrate more energy in the main beam. Simultaneous transmit weather and mapping beams. Wrong. Have a wide beam, as a consequence better target detection. No, for better target detection you need narrow beam width, not wide. Eliminate the need for azimuth slaving. Wrong. So correct option is option alpha. Slotted antennae, flat plate antennae reduce the side lobes. As a result, the energy is concentrated more and more in the main beam. There is no loss of energy. There is no spillage of energy in the side lobes. So that is an advantage. So hence we conclude this lecture, and also we have finished solving all the questions, all 40 questions from Radar Theory chapter in Keith Williams' video nav book. Practice these 40 questions again and again, revise them, write the detailed explanation of these questions with every answer. So you should know the concept, you should know why you are selecting a particular option, the reason behind that. Okay, you should be able to explain yourself if somebody asks you the reason behind your choices. Okay, whatever options you select in the exam. All the best. I will see you in the next video lecture in which I will solve new questions from different chapters, maybe airborne weather radar, Doppler radar, etc. So stay in touch with the studies, stay in touch with studies, stay in touch with all your exam updates, whatever lectures I upload on this YouTube channel. For that, you will have to subscribe to this channel to get timely updates, notifications. Share this video with your friends. Let me know your questions, your doubts, your feedback in the comment box of this video lecture. See you next time. Take care.